Maybe let me just send them to me. So the slides are already in the data tracker. They are already in the tracker now. Oh. So it looks good. I mean, I didn't check them, but I hope they are okay. And with that, I think we can start. So we can get started, I guess. Yes, after. Right. Okay, good afternoon, everybody. There is a little bit of space here in the front. If you want to move closer, feel free. Exactly, yeah. Yeah, we are really flattered by being given this quite nice room. Anyway, let's get started. This is DINRG, Decentralization of the Internet, and my co-chair is Licia Zhang, and I'm Dirk Kutscher. Thanks very much for coming today. And before we start, the usual notes. So we are operating under an IPR policy that is follows the IETF IPR rules. That means if you contribute anything IPR related or you see anything IPR related, you are expected to notify us in a timely manner. Please also note the privacy and code of conduct. So especially, please be aware that this meeting is recorded and will also end up on YouTube, so will be publicly available. Also, let's remind ourselves that we are not in the IETF here, we are in the Internet Research Task Force. That means we are not producing any internet standards here, so we are doing research. Sometimes these groups produce RFCs, and so these are typically or exclusively informational or experimental RFCs, mainly to enable new research and experiments. Okay, so one important thing before we get started, we absolutely need a note taker for today. It's really an important job. Thanks very much, Dave. Much appreciated. So Dave Plonker is doing the notes. And yeah, quickly, as a reminder, so we discussed a little bit in previous meetings, so what could be good outcomes in DINRG and how do we want to document the work. Of course, we have some internet drafts that are progressing. We may eventually also publish RFCs. In the current state of our work, we think it's most useful also to make information available in timely manner, share research results, papers, and so on. And we really like to encourage you to use the DINRG wiki for that. So we set this up, and so people have contributed a bit. But I think we could do still much better. And we think it's a useful, central place to collect some information. Please check it out. And if you think anything should be there that is not yet there, either edit or talk to us. Okay, it's just a snapshot. Another note, so We will have a workshop at the upcoming ACM CONEXT conference in December in LA. We shared the agenda on the main list. It's going to be a really cool full-day event with 2 keynotes, really exciting workshop program. I really encourage you to check it out, and if you can make it by any means, it would be really great to see you in LA in December. And that we have a really nice agenda again today. So thanks everybody who contributed their work and is presenting today. So we start with a presentation by Daniel Wagner about distributed DDoS attacks, DDoS analytics amongst ASs. And then we have Tianyuan Yu talking about the role of DNS names in internet decentralization. And then Mark is doing update presentation of his 2 drafts on consolidation and the effects of it. And then at the end of the session, we reserved some time to discuss future work. So if you are following the mail list, we had a really nice, lively discussion about what people think could be good directions, good next steps for the group. So Alicia and we summarized this a little bit, and then we will kind of use our summary to hopefully open up more discussion today. And with that, let's start with the program, and I'd like to invite Daniel on the stage. And we have a clicker.
Thank you. Where am I supposed to stand?
Probably, yeah.
Okay, so I'm so short. The timer says 82 minutes. That's great. I think I will need all of it. So hey, welcome everyone. My name is Daniel. I'm going to be talking about distributing DDoS analytics among ASs. This is based basically on work already published in 2021 at the CCS. And the work was also awarded the IETF award in 2022, which I was presenting this work in London. We believe in repetitions. So first of all, no great news, I guess. Lots of news. The news, they tell us that DDoS is still a thing, and it's causing service downtime on basically anything that could be hosted online, like financial services, the health sector. It's even used for warfare. When I have to say something from in more recent times, I say, yes, there's lots of DDoS attacks going on related to the war in the Ukraine. All right. In this work that we're going to present, I'm going to talk about, we'll focus on the so-called reflection amplification DDoS attacks, which basically work as follows. On the left, you can see an attacker, which is sending spoofed requests to some machines that he found on the web. These machines are exploitable or running exploitable software, which will then reflect to whatever the attacker chose to be the spoof target, which eventually leads to downtime on this target. Depending on the vector used, the amplification factor we talk about could be something like 50K, the size of the initial request, which is like ramping up the firepower of the attacker. So traditionally, what we see basically all the time deployed is a so-called centralized scrubbing service. There are some companies that do offer such scrubbing services to protect the target from attacks. And this is basically why we're talking in a decentralization working group, research group, about this topic, because our work basically plays in well to see that this can be done in a distributed or more like decentralized manner. And I'm going to present how. First thing to notice is that along the attack paths, which is the red arrows, we have intermediate networks. Since our study is basically based on IXP data, I placed some switch icons, but this can be basically any network that is forwarding the attack traffic along the path. So the question is there any way to make them aware of the attack, since they only see a small proportion of the attack? So local detection is a bit harder than in a centralized manner. And yeah, to basically come to that result that we have a distributed scrubbing service, a decentralized one. As you can see, the more networks are involved in this process, the more red arrows we can cut off short. In this example, I want to just visualize that in our study, or what we're going to present, it's not like we can drop all of the traffic, since we just don't have the global view. So the work basically was split into 3 contributions. First one is kind of apparent. How many networks do we save from the traffic, and how close are we to the reflectors? Meaning in terms of, if we do this in a decentralized manner, how many networks do we free from carrying this attack traffic? Next up, we were looking at what is the collaboration benefit, meaning that if I have a local detection that works, how much can other networks that do not have a local detection or just don't see that much of a traffic so that a local threshold isn't fulfilled, how much do the other networks, if they collaborate, if they join in this decentralized DDoS mitigation fashion, how much of traffic can they drop? So next up, and the last contribution is, how do we get the information exchanged between these decentralized networks? Meaning we have to think of a way to exchange the necessary information while taking into account some things like privacy. I mean, we're talking about IP addresses that are being undetected, so this might be some information that's not easy to be shared. Okay, first of all, let's look at the data set for our analysis. We had access back then, as I said, to some IXP data from 11 IXPs basically somewhere in the world with like different size, different member counts, and some different customer mix. So we see like various types of traffic, lots of flows. This is just for notice. You can look it up later on, but you don't have to memorize all these numbers here. So then we were looking at related work, which is referenced here from a coworker of mine that was investigating what is the, let's say, popular DDoS amplification reflection protocol in the wild, and we came up with this list. So we're focusing on this well-known exploitable protocols, not only by just looking at the transport port number, but also at the typical packet size. Give you an example. If we look at NTP, we have like this 540 bytes, whatever monolith size is. So we were like looking at the protocol and the typical size of the packet that is being sent in the reflection attack. So that basically made us having a data set. And on top of that data set, we once again recycled our approach from 2020 and applied this kind of attack event inference. This is not ground truth. We do not get the attacks really, but we get events that look like DDoS attacks. And for this, we require to have at least n reflectors or source addresses being involved in the data set that send traffic to the same IP address. And the sum of all the bytes being transmitted in these transmissions exceed a certain threshold, which we have set for this analysis to be 1 gigabit. With that, we identified 100,000 events, or I just refer to them as DDoS attacks, and also including confirmed ones. We basically see throughout our measurement period of half a year, DDoS attacks, thousands of attacks every day. We even find one that was confirmed by Akamai. You can see you can see on the lower part of the slide a report by their Prolexic platform that was actually reporting about the attack that we found in our data set. So on top, you can see how this looks like in our data set. We've got 3 networks that saw parts of the attack, and for the topmost one, we can definitely see that this catches the most traffic. So here I would say like a centralized detection would be feasible, a local one, but for the others, this is not feasible. And if they had a way to exchange the information, the decentralized DDoS mitigation would be more effective, since there are more networks carrying parts of the traffic without having a chance to be locally or centralized aware of it. So let's dive into the distribution, the contributions. First of all, we were looking into how many hops away are we from the reflector and from the target. For that, as I said, in our study, we used IXPs. We checked the route server data. So we saw flow coming from the reflector going to the target. I hope that was right. Yeah, that way, from the reflector to the target. And we were checking if we have a route for the source and for the destination in our route server. And then we were counting the length of the AS path. Doing so gave us the first insight, which is that in about 45% of all attacks, the traffic originates from a direct neighbor, meaning that it's just a reflector that tries or starts sending parts of the attack traffic. And if this network, in our case, the IXP, is collaborating in a decentralized DDoS mitigation, it can drop the traffic immediately. And how many ever hops would come after that, they will not see any part of the traffic. So we're freeing the whole internet basically up here. And then the question is, how many networks do we basically free from the traffic? Well, that made us about 70% of the cases, it's at least 2 networks. Coming to the second contribution, the question is, how beneficial is this whole thing? How much can we make other intermediate networks aware if they exchange the information about DDoS attacks? For that, I brought you a couple of plots. First of all, these red bars indicate the attacks with traffic, given from our whole inference when we gather all of the data from the 11 networks. And every red bar means that this network carries traffic. All right, so if we now apply a bit more color to the plot, meaning local detection, we see that for many of the networks, I mean, in the middle of the plot, you can see like right away 6 or 7 networks that don't have any bar for the local detection, meaning that they have a red bar, they carry attack traffic, but they have no chance to see it locally. So that means that if they were part of a decentralized DDoS mitigation, they would be able to drop or detect the traffic that they are actually carrying. So what's the benefit? Now this is basically the inverse as we saw before. We are now plotting the missed traffic. With a threshold of 100 megabits, this can be up to 80% in the case of SE5. Since there is no solid red bar, we see that the global detection does not miss anything, but with the local one, we have like this dashed red bar going up to about 80%. And for the different thresholds, let's look at the 1 gigabit. We see that for SE3, in this case, the missed traffic goes up to about 90% of the part of the traffic that SE3 is actually carrying, but cannot detect it as such. Looking at the last contribution of our work, how do we get the information from A to B? And for this, we envision this big plot, I would say, but let's first look at the top. First of all, we have something that we refer to as a governance layer, since we argue that there are some problems that just cannot be solved technically. We are required to have some human interaction here. There is like a governance body that defines the filters, that defines the thresholds, handles SLAs, since we are inviting anybody to join this decentralized information base that we refer to as DXP. And since anybody can join, people can start to abuse it or just subscribe without publishing anything. We want to have like a kind of a regulation on top of that that processes the abuse cases. Then in the center, we have the distribution layer. This is where actually the information about ongoing attacks is being carried from member A to member B. In this case, this could be a blockchain, this could be basically anything, but in our work, we were thinking about a publish-subscribe system. So we have a DDoS information exchange point here in the middle, where the members can subscribe to and publish their information. Now, lastly, is the question about the confidentiality, is what is the level of information that they are willing to share? And for this, we envision 2 different scenarios. These are now tailored to DDoS mitigation use cases, but it could be surely used for whatever else one is about to decentralize. And then we would have to come up with different kind of confidentiality levels or whatever information should be published and subscribed. Nevertheless, in this case, we have the low trust scenario. This is rather for members that cannot really share information about, let's say, IP addresses of the target or what port is being used due to whatever reasons. We will be evaluating those both scenarios on the next slide to see how effective they actually are. And you will see that even in the low trust scenario, it is effective, so it makes sense to just share the reflector's IP address. Why share the reflector's IP address? Well, there are some public lists where you can look up what reflectors are currently being used online. So we consider this information to be semi-sensitive. And then there is, of course, the high trust scenario where the publisher of the information basically wants to share anything about the ongoing attack, then it's up to him to do. And yeah, coming to the evaluation of that, Let's start with the high trust scenario. It's basically what we saw also in the slides before. The red bars once again indicate all of the traffic that is carrying, all of the traffic that is part of an attack. And then the more and more networks join and publish information about the visibility of the attacks, the overall benefit increases until we have reached all of our 11 IXPs and then have the 120K attacks back again at 1 gigabit threshold. And for the low trust scenario, it gets a bit more tricky since we're just having the reflector's IP address. It's for most of the most of the members not really clear whether this is a DDoS attack or not. But what we found out is that if we boost the traffic that the reflectors send through the network that is now aware that this reflector is part of an ongoing attack by a factor of 10, magic number, but I can tell you why, then we will be coming back to the exact 120K of attacks again. So this is how it looks like. You can now clearly see that there is much more of attacks being detected for the smaller members, which might not be 100% accurate. But the goal with boosting this reflector traffic was just to see that in the end, when we have all of the members back again and sharing the data, we want it to be the purple bar, which is basically the thing that we started with, which is the 1 gigabit threshold, hits the 120K attacks, and it almost does. Summing up, first of all, we've seen that about 45% of the reflectors and about 30% of the targets are just one hop away of the networks. So dropping traffic in network frees the internet. And this effect will improve the more networks join. Then we have seen that in some cases, up to 80% of the globally detectable attacks not really detected locally. And this also will improve the more networks join. Lastly, we have seen then the kind of approach that we propose to exchange the ongoing data attack information. And even with a low trust scenario, we can see that this actually is effective. Well, that's it. Thank you very much. I hope I was on time.
Thanks very much, Daniel. And we have one question by Yogesh. You have to use the mic.
There's one.
I have two questions. You are multiplying the reflectors. What if the reflectors are attacked themselves? Then how you mitigate that?
So the first part was I am multiplying the reflectors.
Yeah, I think you are kind of decentralizing the reflectors. You are bringing more reflectors closer to the endpoint, right?
We're bringing the reflectors closer to the endpoint. If we share, in our work, we do not move the reflectors.
You are increasing the number, right?
In the low trust scenario, you mean?
Yeah.
Yes, I can show you. Yep, on the right part of the slide. We boost the traffic that the networks see once they are aware that the source IP address is a reflector. Does that make sense? We only did this to make, in the end, hit the 120K attacks that we know is correct. But just with the reflector IP address, it is not easy to come up and catch all the traffic back again. Mm-hmm. So whatever we see from the reflectors, we multiply by 10, and then we get about the 120K attacks. This is subject to discussion. No need to do that. I'm just showing that if the members share less information, it gets tricky. So I propose to use the high trust scenario and just share whatever you have. But theoretically, there is a way to share less information and then think of ways to somehow get back to what we actually wanted to do. And the second part of your question was?
I have one doubt is that can we not fix this at source by denying the IP from doing any traffic?
There might be ways.
Yeah, okay. So you're not considering that as part of your solution?
So far, no. Well, but we can talk about that. Okay. So this is like not a fixed thing. This is just what we did, and I wanted to share this with you.
Okay, thank you.
You're welcome.
Next question, Shane.
Hi, I'm Shane Kerr. So I have two, maybe three questions. The first one is, it seems counterintuitive to me that the higher volume of traffic would get less detections locally. You said that 100 megabit traffic, it seemed like it had a higher detection rate than 1 gigabit attack traffic. Am I misunderstanding that?
Where exactly? Can you refer to your slide? Yeah, just stop me. I have to press like 6 times, sorry. Maybe the battery is low, not sure. You say stop, okay? Maybe it was here. Take your time.
I don't know. Go back another one, maybe.
I don't think that there will be any more than this.
Okay. I'm sorry. I mentioned it when it happened on the chat, but I can't.
Whenever it comes back, we can chat.
Okay. Okay.
So then the next of your 2 to 3 questions, please.
The next question was, what did you do to identify and evaluate false positives, or was it just sort of, this is traffic, therefore it's probably an attack?
So first, we were recycling this kind of inference thing from previous work. And in the previous work, there was some work done on that. But still, for this, we also fired up self-attacks against ourselves.
Okay.
I'm not sure if I have that in the backup slides. I can go forward and check. I think I just removed them completely. Yeah, I removed them. There's different things. The boosting factor evaluation, our features and whatnot. Okay. And then we're taking into account. So when I said in the beginning that we were filtering for the prominent protocols, we still have the rest of the data, and then saw that basically with our inference, we will not really see anything besides of that. And then we did a principal component analysis with like, I don't know how many features, 1,000 of some. So we did a PCA to visualize where we actually at, and this is all in the paper. It looks okay, whatever that might mean.
Okay. No,
but we did some work around with that.
That makes sense. And can I slip in one third question, or are we out of time?
So we're really running out of time. If you want to discuss in the end, let's move on. But please use the mail list for more questions.
Yeah, just find me right here.
I'll be really quick, given we're short of time. So this is DINRG. The focus is on the first letter, the decentralization. You mentioned about quantification of collaboration benefit. The question is that, given this work published in 2021, over the last 3 years, I was wondering whether you have gained further collaboration.
I was at a Concordia workshop in the Netherlands and presented this work. And even after the ANRP presentation that I gave in 22, we had a few people stepping in front, asking for whether this is a thing and we can move forward with this. But still, it's like kind of difficult to push the research work into a product with DKIX. So unfortunately, up to the date, we don't have anything operational like this.
Yeah, I would just bring this up as a question. That is, the DDoS require distributed mitigation. How we can kind of further elaborate or grow the distributed mitigation? That seems to be a challenge. I'd be interested in learning more about what might be the roadblocks.
The roadblocks
from building up this decentralized mitigation. I will just stop there, so we can move on to the next one.
Honestly,
we can chat afterwards.
This is more a political thing than a technical thing, my opinion.
Very much so, yeah. Let's talk more afterwards.
Of course. All right, thank you.
Thank you very much, Daniel. Just a second. Okay, let's continue with Tianyuan, and he's remote. Tianyuan, I gave you control over the slides.
Yeah, I can see the slides now. Yeah, thanks. Okay. So should I start now, or?
Yes, please.
Yeah, thanks. Yeah, so given the topic of this research group is about decentralization of internet, so I'm going to talk about like, well, what is the role that the DNS namespace is playing in this grand topic? So think about okay, how can I jump to the next slide? Oh, this one. Okay. So think about today's most of, if not all, user applications are controlled or running at least on the hyperscalers, on Google, on Meta's cloud. And that essentially says we are creating reliance on the cloud controllers, cloud providers. All the data or the identities are captured by the cloud providers. And There's one way out of this, that is develop a new kind of generation of applications that really controlled by the end users instead of the cloud providers who are hosting resources for us. So think about if we want to build this kind of application, what should be the necessary step to enable this? I would say the first step is we need to enable direct, of course, secured user-to-user communication. And one way to get there is to let users have DNS names so that those names are at internet scale. So users can authenticate each other just using standard like security solutions. And people know we can authenticate DNS names in many ways. So if user can authenticate each other on the internet without reliance on extra like PKIs, user can pretty define, okay, this is the trust policies for my application, and the application data is definitely in user's control. Well, I think the slide's not working well, but fine. So think about if we just have to we just want to collaboratively edit one document. And of course, we need to have some trust model that we are in the same group of document editing. Say, this is the group, say namedata.net, and we are 2 users. Then we have to if we can assign DNS names, or we have to if we have to have some identifier, say this is Alice at namedata.net, and this is Bob at this namedata.net. So those kind of identifiers, those are they are either email address or identifiers controlled by the company who provided the resource. Those are not the real identifiers controlled by the user themselves. If we can utilize DNS delegation system to assign DNS names to users, then we can really have the names directly under user's control, because, well, your DNS name is yours basically. So if we can have that, the Alice and Bob, the two, can just on the internet, they can just say, okay, I'm Alice with this DNS name, and I'm Bob with this DNS name. After the mutual authentication, the rest of things are just a security communication, and we know how to do it with this technique. So, well, think about I own a domain name called tianwen.me. Then if I want to create this collaborative editing application, I say, okay, I delegate a sub DNS name, say mygroup.app.tianwen.me, and whoever trusts me, say Alice, I can further delegate another name to it. So Alex, in this application context, would have her own DNS name, and so does Bob. So that says at least between among three of us, me, Alice, and Bob, we all have global DNS names, so we can directly authenticate each other on the internet. And with that, think about if the picture is only among 3 of us, we do not necessarily rely on the DNS or web PKI, because whoever trusts me can consider me, my key, as a local trust anchor. So everything is in the trust circle. We don't have to rely on the extra DNSSEC root or CA root. With that in mind, we can say if user have DNS name, then published data is merely publish another data under your name. You can have, say, for blog posts, you can have the blog/post/ the post name with some identifier, and making document edit would say this is my edit, this is my sequence number, and this is the brief description. And we can encrypt the object by using your own key, not controlled by any others, not controlled by cloud. It's purely controlled by yourself. And this piece of data is signed by your key. Every security solutions is controlled by yourself. Then after we have this secure name data, then the rest of the story is just to exchange them. Think about if you already have this piece of name data, the best way to exchange them is to have a kind of overlay or overlay networks that can authenticate, that can communicate data by names directly. Say, if I'm Alice, I just connect to the overlay network, say, hey, I'm Alice, and please tell others that I'm hosting the data prefix here, so that others can like request data from me on the other side of the world. And we did practice this concept generally in an application called Workspace. That is a local first application, and we did have a talk on early this year. And on that talk, we mainly focus on the functionality and say, okay, you can have your own identity and you can do like document editing just like a Google Doc or Overleaf. But the point we really want to sell there is to say this is an application that can decentralize the control power of your identity, the control power of user data back to users by employing the DNS name as usernames. So again, we have these DNS names as application name under, say, my domain name. Then essentially, each of us, like Alice, Bob, and I, we just publish secure name data. Then we connect to a name data network to exchange them. And this essentially create like a small house or shelter that keep the clouds outside. We can keep the Google outside. We can keep the Microsoft outside. The trust is purely among three of us. There's no others. This is purely user-controlled application. And when we want to exchange data, we just register prefix saying I'm hosting data under this prefix. Then others can request data from me. So we can exchange data for this request response model on this name data network. And in practice we are using an Indian testbed as a network provider for us. It is exactly an overlay I just talked about. Say all the Indian speaking nodes can connect to each other by the tunnels with its own application trust anchor. We don't have extra reliance on the PKI system. And the network as a provider, a testbed as a network provider, it accepts routing announcement after authenticating. If after authenticating you are the prefix owner of this specific name. So we essentially, the network provider testbed basically, I would say, immune to route hijacking because it really first really authenticates you as a prefix owner before accepting your announcement. So the thing about the general idea is to say assign DNS name to users, and the Workspace is only one application we have built based on these ideas. But there's also like other works sharing the same idea that with multiple. So first, I will mention about the dance. I hope people here all remember Dan. That is, that dance proposal essentially says the TLS client can also have like X509 certificate, and in their latest the draft, this is as I read, domains who publish the TLSA record for under a specific like underscore username can essentially serve as the identity proof of an user. So that is equivalent to assigning a DNS name to users and using the TLSA record as authentication. We also see like similar things in Blue Sky, that is a decentralized social media. It says if you control a DNS name and you can prove you control a DNS name, you can try. I can bind your DNS name to a flag ID so that your identity, your key identifier can be permanently bound to a DNS name that you can use in other places in communications. And we have Geoff here. So if I quote your slide in Nanog, you talk about we are essentially moving from a peer to end-to-end networking model to a more like producer to consumer network. We just request data and get data reply, and the clients today are not identified by the public address anymore, because we know address doesn't mean anything in terms of applications. And we know service today are really identified by the names. So we have already observed that the internet already shifted from the address-based host-to-host model to more like a name-based services model. So if we step up a level on this topic, that is, in today's network, naming is the very first and the important things in networking. We have host names, we have service name, data names, user names, so on and so forth. Then networking today is based on DNS names, because it is DNS name who empower like applications with semantics. It is DNS name tell us what this data is doing about, what the service is doing about. And if we think from that level, it is necessary to give user DNS names to enable like user-to-user communication, who can essentially enabling user-controlled applications such as workspace, and that would be an effective step working away from today's centralization situation. Yeah, I expect questions from people.
Yeah, question by Jens. Thanks, Tian.
Hi. It's not a question, it's two comments. I'm here on behalf of DINRG, the German DNS registry. I'm saying specifically to take that hat firmly off. DNS is deeply hierarchical. Any registrar can take your domain name away from you and therefore kill all of the identifiers that you've issued. Might not happen, but there is a very strong centralization of control in DNS. Now, that's one thing. Number two is, you were speaking earlier about removing, decoupling identifiers from cloud providers. In this scenario, you are the cloud provider for the users that register the name in one way or the other with you. I don't think this creates the incentives that move towards decentralization, because we've had this before, in the sense that you already had the ability to go to a cloud provider and register a name there before. I do not, maybe this is a question, I do not see the fundamental difference here, except that you have a different trust relationship. But when the internet was smaller, when the web was smaller, that trust relationship also existed, and we're no longer there. So I want to see the difference there, basically.
Yeah, I understand. So yeah, for the DNS name part, what I'm thinking now is, well, DNS namespace by design, it is not centralized controlled. The centralized control part happens, I mean, by system design, it is not centralized. And if it belongs to organization can delegate a sub namespace to you, essentially. And it is also easy to get your own DNS name. I don't think that's a big deal. You must know that. So I don't think DNS is a centralized control system. That's my personal understanding on that. And for the second part, I think the real, for the control part, I think the real thing is I'm also another user. That is the key point. Because I'm just like a Google Doc. I'm the owner of this documentation. So of course I have a right to say who can join this effort. So I would say users are in control, and in terms of who run the resource, who provide the resource to run applications, well, someone for the resource you have to pay, but you won't say the electricity company they are centralized things, right? Hope I answer your question.
Kind of. Let me perhaps rephrase this. When I think of decoupling an identifier from a cloud service, I'm thinking that I have 1,000 different user accounts right now. I do not see this effort changing that, because instead of having 1,000 accounts with cloud providers, I will have 1,000 accounts with different peers, which is arguably better, don't get me wrong, but not substantially different. I still see my identifier being coupled to a particular thing that is under somebody else's control.
Well, if I get to answer this question, independent from the talk, understand that the so-called centralized control of a DNS namespace is all about the TLDs. And how many TLDs we have these days, I don't know. Before it's 1,500, I think they get more. The question is, you don't have to get your username under GitHub. I get my username from my department. How many I want, I can get as many as I want. So it's really is abundant DNS namespace that allows anyone get a name and you further delegate. Don't hang on the well-known namespaces. All you need is authentication of the name foobar dot something something.
That part is correct, yes, that I agree with.
Also about the motivation, I just share a story. I mentioned this workspace since it was presented at the DINRG some time ago to a friend. And he said, hey, whenever your code gets mature enough that it doesn't crash all the time, I'll use it. Because I hate to put my internet draft into a place where company X can really steal into it.
Okay, we have one more question from Nyal.
Neil O'Reilly. I'm wondering what's the compelling case for using the DNS for this? We already have instances of things like Element and Nextcloud that we're using to get decentralization of the concrete resource and overlaying a namespace on top of that. I'm wondering what's the advantage?
Yeah, I'm thinking because if your identifier still depends on a server instance, then essentially says your identifier is still in the server's control, not in your self-control. DNS name, as long as that's your DNS name, you can control that identifier. I think the difference is in control. If you interpret decentralization as self-hosting service, and you just register an account as that self-hosted service, then you still don't have your own identifier. I don't know if that answers your question. Oh, yeah.
I'm not sure. I'll leave it there for now. We can find each other on the mailing list again. Thanks.
Okay, thank you, everybody. There are a few more questions in the chat. So Tianyuan, if you have time, maybe you can have a look and try to continue the discussion. We have to move on, and I'm inviting Mark McFadden to the stage. It's a long way, I'm sorry.
This is pretty amazing. This is the first time that I've been at an IETF and been on site where I still feel like I'm remote. No, I'm going to just use that to lean up against. And this works? Great. So this is an update on 2 drafts that we've been contributing to DINRG for more than a year. In one case, almost 2 years at this point. Let's see here.
Can you try maybe? You want to go next?
Yeah, no, go ahead. I'll just say next slide. This is a reminder from the charter for the research group. DINRG's main objectives include a long list. This is not the entire list from the charter, but I picked out these 3 things to explain what the motivation is for these two drafts. And so we're talking about things like root causes, but also metrics and measurement. And then this last bullet, characterization and assessment of centralization, is important to one of the two drafts that we're going to talk about. And move on. So the two drafts here is one's titled on the effects of internet consolidation, and I'll talk about that first. The second one is the slightly newer one. It's the taxonomy draft that was most recently presented here at DINRG back in San Francisco. Next slide, please. So the first one here is consolidation effects. And this is an update. And so one of the things that has happened here for the Dublin IETF is that we did get comments back in San Francisco, and I also got comments after Vancouver. And so I took those comments. Some of the comments were on the mailing list. Some of the comments, a good chunk of comments came to me directly. And we took those comments and have created this 04 draft. The idea here is not to duplicate the material that is in Mark Nottingham's RFC 9518. Instead, the motivation for this draft is really to answer this, this objection that I hear all the time, and that is that consolidation and centralization of the internet is an economic effect, and it's only economics that makes this possible, whether we like it or not. And so we're not economists at the IRTF, and we're not economists at the IETF, and so you shouldn't really talk about centralization or consolidation. And I and my co-author think that's wrong. That's completely wrong. Is that, in fact, economics plays an important role in centralization, but it's not the only thing, right? And so the point of this draft is to argue that there are other things outside of economics that lead to centralization. And most importantly in this draft is the contention that actual protocol design leads to centralization. And at the end of this draft, or sort of towards the end of this draft, there is an argument that it gives examples of particular protocols that actually do this. DNS over DOE, DNS over HTTP is an example here. Another example is Privacy Pass, and those examples are actually in the draft. So the argument here is that we're arguing against what's in this last bullet, this objection that we've heard previously, and is very emphatically argued that centralization that we see in the internet is a product of economics and economics only. We think that's not true. Next slide, please. Thanks. So is there a relationship between protocol design and centralization? Some claim not, as I just said, but we think there are clear examples where protocol design bakes in centralization. Let me say that in simple English, that the protocol design that we do here at the IETF actually demands that centralization be built in, okay? Now, there are lots of people that say, oh, well, like, what's an example of that? Well, the examples are in the draft, but there are examples like Privacy Pass, which has a set of features that make it so the number of issuers has to be very limited, or the rate at which those issuers are issuing tokens has to be very limited. That's a very interesting design. It's in the Privacy Pass architecture, there are 4 different basically sub-architectures or ways of actually implementing Privacy Pass. And not all of them suffer from this problem. But in fact, 2 of the 4 actually have this baked right in. At IETF 117, one of the arguments, someone came up to the microphone as I was presenting at that time, and they said, well, look, economics of scale is the primary driver of centralization on the internet. And the forceful example is that it's the network effect, right? As you get more and more users using a particular product or service, then that service gets big enough to offer more services, more people like those services, the service gets bigger, and so forth. You basically have a network effect that makes the economics of scale actually multiply And that's what allows a small number of organizations to control a lot of the infrastructure of the internet. But the argument here is, first of all, to not say that that's not true. That is true. But one of the things about that is that that's not the only cause of centralization. And so this particular draft argues that you need to look at other causes as well. Next slide, please. Thanks. So this draft has changed in a lot of ways. First of all, we've changed the discussion around economic centralization and to centralization of power. One of the comments that we got was that too often when we talk about centralization on the internet, we talk about economic centralization, but it's actually centralization of control and power. That's the interesting part. And so that allows for a discussion of a whole bunch of other symptoms of some centralization. So what we did was we left the economic discussion in place. It plays an important role in this draft. And then we added the idea that centralization leads to imbalances of power in other ways, imbalances of power and control and so forth. We got asked by two people who provided comments to us to talk about the difference between centralization, consolidation, and similar terms. Very early on, when I was at a microphone at DINRG, people came to me and said, well, what's the difference between these? Do we use these words interchangeably? Do they mean the same thing? And so we gave some thought to how they are perhaps subtly different. And in section 5, we left the discussion in place that was already there and put the discussion of these words, the definitions of these words, in the second draft, which I'll talk about in a minute. Another thing that we added to this draft, because once again, based on requests that people had comments for, people asked us, well, you can't actually tell if things are getting better or worse if you don't measure them, right? And so what metrics do we have for centralization? And so what we did was we wrote an entire new section on metrics and measurement for this. There are lots of, as you can imagine, there's lots of other smaller editorial changes, but these are the three big ones that came from comments from the research community here, and also other people who had seen the draft. Next slide, please. Now, the second of the two drafts is the taxonomy draft. This has been through one more revision. Once again, the last time that I presented this, it was at Prague, and I did get comments on the mailing list. I got people who came up to me right after that presentation, and this is a completely different draft. This was a draft, again, for the research community to sort of say, look, when we talk about centralization and consolidation, some people are talking about one thing, other people are talking about another thing. Let's admit that there are different kinds of consolidation and centralization. And second of all, if we admit that, then maybe what we can do is actually talk specifically about each kind and provide a taxonomy of centralization. And that's the purpose of this draft. So in that way, it's completely different from Mark Nottingham's RFC and also the effects draft that I talked about before. This is really intended to address the issue that I found when I was coming to DINRG, is that people would talk about one thing and then people would get the microphone and talk about something else. And they were talking about different kinds, different parallel tracks of centralization. So this draft, just for review here, it divides the consolidation framework into 4 parts. Economic consolidation, of course. Traffic and infrastructure, who owns the cables, who owns the fiber. Architectural consolidation, and then at the application layer, service and application consolidation. Next slide, please. This is a reminder, a really helpful RFC 8890 says, it says many, many things, but one of the things it says is that inappropriate concentration of power on the internet has become a concerning phenomenon, one that protocol design might have some influence upon. Well, the first draft obviously addresses that. That's one of the important arguments in the first draft. And now, if I go to the next slide, one of the things that people said about the taxonomy draft, actually I had 2 people come up to me and say, look, this is all about economics. Your other 3 parts of the taxonomy, that's interesting, but that doesn't really play a role here. And so what we tried to do in the taxonomy draft is revise it so that we can show that it's not the case that it's all about economics. Economics is certainly an incredibly important part of this, but it's not the only part, right? Second of all, people came up and said, look, you're using these terms interchangeably, consolidation, centralization. What, do you mean the same thing or are they different things? And so what we did was we wrote an entire, a new section, section 2.1 of the draft, that tries to distinguish between these terms. That I truly believe is a work in progress. I think that's a hard thing to do, especially when you think about in your mind the differences between centralization and consolidation. Consolidation is really a limiting of choices. Centralization is consolidation of power, right? And so section 2.1 tries to deal with that, and that's brand new in this draft. It turns out that one commenter came to us and said that economic centralization should be an example of consolidation of power. So we tried to do some, we did some new text in section 4 to address that comment as well. And we redrafted the section 6.3, which is the relationship between standards development and this new taxonomy of centralization. Next slide, please. What's next for these two drafts? Well, first of all, it's I think a work in progress, right? Let's admit that. And we're very happy, both and my co-author are very happy to have comments. The references have been completely reorganized in both drafts, but updates certainly are possible here. I think that the drafts as they stand are kind of stable, but the first bullet is the most important one. I think we're very happy to have other comments, other suggestions for improvement. And then finally, both drafts have been presented twice here at the research group. We'd like the research group to consider adopting them rather than having them be individual drafts and have it, not necessarily, I know we're sensitive about publications, not necessarily for publication, but have them as drafts, that they're research group drafts. And that's it. Thanks, Dirk. Thanks, Lucia.
All right. Thank you very much, Mark and co-authors, for doing this work. It's really much appreciated. And we really think it moves the group further forward. So that's really, really useful. Yeah, regarding the question of adoption, so we will have to follow up on the mailing list. So everybody who has an opinion on that, yeah, please weigh in. And so question to you, Mark. So what would you like to get from the group at this point? Is there something specific that you're looking for?
Well, specifically in the first draft, the thing that I think is most important is, do we successfully make the case that economic consolidation is not the only source of consolidation on the internet? And if we haven't made that case, or you're not convinced, or I hate to put words in his mouth, or if you're Jeff Houston and you think that everything else flows from economic consolidation, then we need to do a better job of in this draft of making that argument. So that's the first thing I would ask. The second thing I would ask is that if people have other references that they would like me to include in that first draft, I'd be very happy to do that. In the taxonomy draft, one of the things that we have been, we've got comments on are these 4 categories of consolidation. Are they the correct ones? And are they described appropriately? So that would be the first thing that I would ask. And Dirk, the second thing I would ask is that in the new version of the taxonomy draft, there are definitions of centralization, consolidation, and a couple other words. It's important to our work in this research group that we know what we're talking about, that we all have a common understanding. And so if people have feelings about that, it's in, I believe, section 2.1 of the taxonomy draft. That would be really helpful as well. I will say, though, that we'd be happy to have any comments, but those are specifically what would be great.
Okay, great. So we have a few people lining up for questions in the queue. So Raul is the first.
Hey, Mark. So I was there in Prague during the meeting. I tried to even catch hold of you, but unfortunately I couldn't find you. So I'm hoping I might be able to connect with you this time. So one comment that I had even then, but I didn't have the right terminology for it, but I think I have a better handle of this now, is that we need to consider, to understand internet centralization, we need to consider centralization from the perspective of computers themselves. So you have to look at the history of hardware and software, because those are the places where centralization occurs. So one major thing that I discovered very recently is there is this entire movement called malleable software, which basically says we should abandon the practice of even having application packages. And the idea here is that applications themselves are a form of centralization. And then when you put those applications on the web, web applications have the centralization power of being packages, and then they have network effects. So the two together become this very, very potent force, which leads to millions of users coming into one platform. And basically, this is how platforms are start to emerge. So maybe I would like to see more discussion on that. I do not have my ideas fully formed myself, but it's something I think it's worth considering to step back a bit and then proceed.
So I appreciate that, and thanks for that comment. The first thing I would say two things. The first thing I would say is that in the taxonomy draft, the fourth of the categories of centralization is service and application consolidation. And so I generally agree with you that at the application, at layer 7, there is tremendous centralization, right? And I won't pick on any companies here, but we all know what I'm talking about. The second thing I'll say is notice in neither of these drafts, and this is more than I can possibly hope to do, but none of these drafts are prescriptive, right? It doesn't say, here's the problem and here's how to fix it. It just says, here's the problem, right? And I've gotten feedback from people that needs to be added to the draft. But in the interest of time, we'll go to the next question.
Next question is me, actually. I think I thank you very much, Mark, for the revision. I believe both drafts get improved a lot, especially the first one. But I do agree with Jeff's comment he just made online regarding the motivation for centralization. I think it is money. Maybe you meant to say something different. That is, the drive for decentralization not necessarily start with the big money in front, dangling to say, hey, go this way, there's big money there. That's not necessarily true. I think people make trade-offs to see how much you actually pay versus how much you gain. If there's a bigger gain, there's attraction. I'll stop here for the shortage of time.
Jim Reed.
Yeah, Jim Reed.
Oh.
Hey, Mark.
Hey, Jim.
Thanks very much. Very thought-provoking talk, and this is a very fascinating area of interest, I think, not just for DINRG, but for the IETF in general. You partly answered the question I was going to ask earlier, but I'll repeat it anyway, which is, what do you think the next steps should be? And I'm wondering about some of the considerations we're talking about here about whether the economic incentives or not, maybe that the IETF needs to look at having a much more multidisciplinary approach to these kind of issues. One thing that's been bugging me for a long time, for example, is some of the economic incentives for deploying protocols are truly perverse. Secure DNS is a good example of that, in my opinion. But I wonder what you thought about other ways of trying to consider this problem in the large, and where you think we should try to, where and how we should try to progress that.
Well, the first thing I'll say is I think the chairs have put aside time on the agenda to talk about just that here after they kick me off the stage, which you can't see it here on the stage, but that's what they're doing. And I guess one of the things that I've sort of wondered is that one of the ways in the IETF that we've promoted more consideration of a particular issue is to require a section in RFCs that deals with that issue. So when in the 2000s we started worrying a lot about the relationship between security and protocols, we said that in what is it, 3152, we said that every RFC had to have a security considerations section, right? And then just a little later, we said that there's a relationship between protocol design and protocol registries. So every RFC needs to have an IANA consideration section. What if there was a centralization consideration section, right? That at least the protocol designers would have to think about it and the ADs would have to respond to it. You would at least have some consideration of those issues in the future, right? I think another thing that is in the future of DINRG is sort of what I was talking about before. These are kind of reference documents. These are things that are supporting future research, and that's really what they're intended to do. But I think that there is a prescriptive element here that would be hard to get consensus on, but would be something that would be worth at least talking about. And so those are the things that come to mind, Jim.
Okay, thanks, Mark. Thank you.
Just a quick comment. So we reopened the queue because we think this is actually a very useful discussion also in terms of future directions and future work. Arnaud is next.
Yes, Arnaud Tadei, Broadcom. So in the panel, sorry, in Vancouver, I spoke about there are other considerations we could have here. And especially there is the Digital Operational Resiliency Act of the EU. I don't remember how many times the term concentration is listed there. There is even an entire article, multiple articles about that. And I wonder if it could be a good idea to study this text, because it's a real text in force 25th of January, so very soon. There is a lot of work behind it on what are called regulatory technical specifications and other, and it is cascading to other things. And I really would like to understand if, when we spell the term concentration on our side, how it overlaps, does not overlap, or is the same or not the same with this term of concentration. And I think it would be interesting to explore if we have a gap. Thank you.
So I know that's helpful, and I think that's a great idea. I think one of the things to know here is that, at least for me on stage, I'm not an economist, and I'm not a regulator, I'm not a legislator, right? I do know about the act, but the intersection between these issues, consolidation, centralization, and regulatory, what potential regulatory controls are in place, is something that is much fuzzier to me, right? And we know that there are people who believe that we can't regulate our way out of this problem, right? There's some very intelligent conversations about regulation isn't going to change that. But there are other people who believe that that's exactly what we should be doing. We should be protecting markets so that the markets are fair. We should be protecting access to the market so that new entrants can get in there. But that would be a draft from someone beside, that wasn't me.
Thank you, Mark.
Yep.
Hi, Colin Perkins, as an individual. I think I was going to echo the point Jim Reed made, and I think I was coming to a similar point to the one you were just making then. This distinction between economics aspects and centralization of control and so on, to me seems one of the fundamental questions here. What I wonder is how we can answer the question, and whether we can find people with the right expertise to help us answer that question. Because it seems that you know, we're a bunch of engineers and we have opinions, but there are perhaps other people we can find who may have more informed opinions on that subject.
So I haven't given this talk, but I've given a similar talk to other groups. And what happens is that sometimes in those places, there are people that don't have our skill set, but have other skill sets like economists, policymakers, and so forth. And they've been very encouraging. Some of them have even said that they're willing to come to the IRTF and write something. Haven't seen it yet. When we were together in San Francisco, there was an economist in the back of the room who said, who was one of the people who made the comment that this is all about economics. And he offered to draft an internet draft along those lines. I think, Colin, my answer to your question is that we're trying to do outreach the best we can. There's this great conference in December. And I think we continue to make that effort. I think that's what the research group is built to do, trying to bring more and diverse people, at least into the research group.
Yep, absolutely. I fully agree. Thank you.
And so we have an economist at the workshop in December. So, Jens.
Yes, thank you. What I wanted to say was a comment which is kind of a possible answer to Colin here. I can't help but notice that this shift from, I haven't read the draft, I have to say, so that I should put up front, sorry, I want to do this now. This shift from economics to power imbalances, I think, is where you might find support in the human rights policy consideration groups, because in a sense, much of what they do is about power imbalances. But of course, in a completely different context, but still some things might transfer. That's all.
Well, it was a clear comment that came after Prague, that another way to frame the conversation is to talk about this imbalance of power. For instance, one of our previous speakers today on the agenda, right, was talking about user-based networking versus the traditional forms of networking that we have. And I think that there are a lot of people that have that at the back of their mind, right? And if you think it can be, when you have a chance to read the drafts, if you do, send text.
I absolutely want to, yeah, thanks.
Yep.
Raul.
So to Colin and Jens's point, and this is a request that I've already made to the chairs. We should actively be looking out to bring in other expertise like economists and regulators, and maybe in this case, anthropologists to sit with us and give us their skill set and what input they have on decentralization issues.
Yeah, I will say that one of the things here is that there is quite a bit of academic research, but it's not directed specifically at the internet. There's actually not a whole lot of academic research to use as a source for us engineers to think about this problem. And so I'm hoping that conferences like the one that's coming in December help sort of prime the pump and bring us some more of that well-grounded academic research.
I have to agree with you. Once we announced the workshop, someone commented to say that it's so great there's such workshop on internet decentralization. This is the very first in the academic world. Yes, I hope it's the first, but that will lead to more to come.
Excellent. All right, thanks for the extra time.
Okay, yeah, thanks again for doing this. And yeah, we'd really like to invite everybody to read these drafts and provide some feedback on the list, and also think about what you think about adopting these drafts. Okay, so we have a few more minutes left. So we won't have much time for discussion, but we just wanted to summarize the discussion that we had so far. And so the background of all of this was that, okay, we had the DINRG Charter, and we mentioned a few things that we think are probably still valid, such as, talking about identifying root causes, measuring centralization, and so on. But we still think it's kind of healthy for us to reflect a little bit, and so on what we have been discussing, let's say, in the past month and years. And so we think there has been some, development of better understanding, and yeah, also some maybe better ideas or new ideas of so what a group like this could effectively do and should effectively do. And so let's just quickly summarize what many of you have discussed on the list. So thanks very much, everybody, for participating in the discussion. So we had a bit of discussion. So what does this actually mean, decentralized, and so on. And so also today we touched upon this a few times. So yeah, we kind of learned, or like many people made this point that it's probably really useful to distinguish between like technical centralization and so the actual centralization of control and power, and and also mechanisms for exercising this control. And so in this discussion on the list, there were contribution towards this, like both of these directions. So yeah, so the technical or physical centralization discussion kind of went like this. So there are some systems that claim to be centralized, but if you really look at how they are deployed, they're actually not so much centralized. So lots of cloud concentration for these systems. Then there were a few discussions. So is it a problem? So is big always a problem? Is it just complexity, or there are other problems? So that's like was one let's say strand of the discussion. The other that also came up today again is yeah, the actual control power centralization. Although you can say some of these systems have like decentralized structure for like communication, perhaps, you still need to look at who's controlling those systems. For example, Jens made the point, who's actually controlling the algorithms that are employed. And then the other argument is that if, like, we also discussed about identity and names today. So if users don't have independent identity for communication through a system, they cannot communicate directly. So that is a natural tendency towards centralized authentication providers or gatekeepers even. And so there may be some similarities to like discussions in other areas. So in the chat, I saw some discussion about people don't believe that internet protocols can actually help with decentralizing the current system. And that's probably true. I think that's certainly something that we suspected for a long time, but I think more and more people acknowledge that. And yeah, so here we have thought about this analogy with like Bruce Schneier's work on cryptography, where he was much more optimistic when he wrote his book Applied Cryptography, and now is maybe taking a slightly different perspective, that you cannot solve some economic or socio-economic problems with technology. And then there was a discussion on, yeah, a bit more on the, say, constructive side. So, what to do next. And Christian Hüttemer made a proposal. So it could be worthwhile to think about, how to commoditize a number of platform components that could be useful for like more decentralized system designs, and also creating new applications in the future that are not falling into the same like trap of centralized platforms. And yeah, so what he proposed was to think about, so could it make sense to support or discuss the development of a few applications, and then learn about what are the useful platforms that you can generalize and derive from that. So of course, a research group like DINRG will not be a place where we develop lots of applications and do lots of software development and so on. But I think the way that was meant here is that, okay, this could at least be a forum where actual research, actual development that happens outside or in the community could be discussed more. And we are also common knowledge could be obtained by sharing ideas and results from that. And yeah, of course, this would require actual work. We need to think about, and there are some developments that we discussed here before, like local first computing, local first software, and so on. So there may actually be some interest in the larger community, not just DINRG, in this direction. So there were a few more things that were discussed, but so these were the ideas that we thought would be worthwhile bringing up here. And so our summary from that discussion, which we thought was very, very good, but there were like three main topics that were mentioned. So measurements, so continue to measure and document the level of centralization, its effects, new developments in that space, but also maybe assessing some of the so alleged alternatives or solutions a bit more critically, and yeah, discuss their actual degree of decentralization, but also their utility. So how would they actually be helpful or not? Then I think we have made actually good progress in improving our understanding, and also thanks to work by Mark and others, developing a better terminology and taxonomy of these systems. We think that that should definitely continue, and yeah, analyze the system issues versus control issues, but also continue to really look at the root causes and possible mitigation strategies or non-strategies. But so the one idea that yeah, was brought up by many people again today, but also earlier on the list, was like this naming identification discussion. And yeah, so the question of like overcoming decentralization, I think that deserves probably more discussion. So, to what extent can DINRG be a forum for promoting this, or for encouraging more discussion, maybe also connecting communities? So our question to you, would be, what do you think? So what is the best realistic role that DINRG can play in a credible way? And so we think we have some people here who are doing active work. Probably need a few more to have like more viable discussion and continuous work in this direction. But we would definitely be open to discuss it. So now we have like 2 minutes left. If there's an immediate reaction, we'd like to invite people. The main purpose for presenting this was to basically inform all of you and kind of summarize the discussion. We definitely should continue now on the main list, but I see that Raul has a comment or question.
So, Dirk, my question for all of these things that DINRG envisions to do, I mean, do we have the kind of resources for it? Do we have ways to fund individuals to take this work forward? Because it's a lot of us are just contributing from our own time, so we can't give make a more serious contribution as a result of that.
Well, and it's the question of resources basically depends, right? So on what people are willing to work on, and at least for like the academic people that are involved in the group here, I mean there is ongoing work to like addressing some of these say more practical or also software development related issues. But it could not. I think it will not be the like main focus of this group, right? I think it's definitely a topic that would be interesting to discuss. But there needs to be activities outside this group. So yeah, research projects, maybe open source projects, and so on. It's definitely would be I think great to see more of that, but because we cannot do this all by ourselves here. Anything from the chat that I missed?
Yeah, Jeff pushed back, so I'm asking him why not just speak out.
Okay, so here comes Jeff.
God, it's bloody 1:30 in the morning. Look, that summary is kind of one-sided. It's sort of the results, not the causes. It doesn't really sort of gain any traction with attempting to understand how we've got to where we are. And, you know, I have to say, in some ways, this is screaming out for some kind of study about the economics of centralization in other industries in the past. You know, how have we come from in the past, and how does that relate to the internet? Because as far as I can see, nothing about this situation is novel, nothing at all. Many other industries have gone through precisely the same situation. And in many cases, we've just simply gone, well, okay, we're going to come to terms with that and accept that as an inevitable consequence. You know, this is just a small number of players. The airline industry, the car manufacturing industry, you know, a lot of these things just centralized up like crazy because of the demands of capital and resources. And, you know, the result was inevitable. In this case, in the internet, it wasn't necessarily a resource demand that created centrality, but it was certainly an issue around a rapidly changing base set of environments, you know, that revolution of packet switching that reshaped it so quickly that a small number of players got to grips with it faster than everyone else and occupied the space and became heavily resistant to competitive pressure. Now, once we start talking about economics, competition, and entrance into markets, I think we're actually getting more to the core of what the issues are that drive centrality. This summary just talks about the effects and quite frankly is just skating at the top level. Thank you.
Okay, thanks, Jeff.
We are on the borrowed time for people to take coffee, so I'll be very short. I think, Jeff, not everything, not all the revolution started by having a big pile of money dangling in front to say, hey, go this way. Internet did not start that direction. And I think many other innovations didn't start there. So centralization definitely has that dangling in front. Decentralization need to take a different motivation. I'll just stop there.
Okay, I'm really sorry, but we have to get out of here.
Okay, I just want to announce a side meeting, if it's okay.
Okay, quickly.
Just tomorrow at 1, there's a side meeting on the multi-formats working group proposal. There was one yesterday. I was unable to attend remotely on blockchain name systems. So just in terms of, you know, community work, like I think there's a lot of stuff that never gets a working group that wants a place to get IETF feedback.
Yeah, so please send a note on the mailing list. Thanks everybody for coming. It was a really nice discussion again. And thanks very much to Dave Conker for taking notes. Much appreciated. Thank you. Bye-bye.